Here's an example of how SDS2 can import connection loads from a spreadsheet. This video is specific to one engineering firm that uses a different analysis software and exports a specific file type. The point is to demonstrate that we can import connection loads from a spreadsheet as long as there's a way to tie these loads to the members in the model. In this case, the engineer produced an IFC file which contains a RISA piece mark for each of the members. Start by creating a new project, and for flavor, select Floor RISA Data. Next, go into Member Label Configuration and set it up so that the RISA member labels will appear at the start ends of each of the members. Import the model by selecting Design Link. Browse to the IFC file which was sent to us. In the import options, uncheck Prompt for Unrecognized Materials and check Remove Piece Marks and Import Custom Property Sets. For post-process script, select the Python file named Floor RISA Piece Mark. Then select the properties that you would like to import. In this case, we're selecting RISA labels, which will correspond with the connection loads, which can be imported at any time. You have the option to import the connection loads now. I will select Cancel and import the connection loads later. To be completely honest with you, there is some cleanup work involved which is not part of this video. The cleanup work involves tasks such as adding base plates, moving brace work points to the half depth of beams, deleting material, and adding views. For this model, cleanup took less than 5 minutes. For a huge project with thousands of members, it might take a couple of hours. The model shows the RISA labels at the start end of each member. Notice the vertical brace, which is piece mark M56. In this case, the start end is at the right end of the member. The default connection loads are set to auto, which is defined in your connection design criteria settings. We're going to design for the actual loads, which we'll import shortly. Here's the connection loads table, which was provided by the engineer. For ease of viewing, I highlighted the loads which will be imported into the model. The values that are imported are a function of member type. For instance, for braces, the values imported are start max axial and start min axial for tension and compression loads at the start end of the brace, and end max axial and end min axial at the end of the brace. Note the values for M56, which are 115 and 150 at the start end, and 121 and 163 at the end. For beams, however, instead of importing the beam axial force, the transfer force needs to be provided in order for SDS2 to properly design the connection. So, for beams, the values imported are start max axial transfer, start min axial transfer, start FY, start MZ, and the same corresponding values for the end of the beam. Make note of the values for M14. To import the connection load, select Model, Parametric, Run. Select the Python file which we named Floor RISA Piece Mark, and then browse to the spreadsheet containing the connection loads which are imported as soon as you hit OK. Then select the Process button, which will design the connections and create solids in your model. Let's take a look at brace M56. You will see that the loads of 115 and 150 were imported at the start end, which in this case is the right end, and 121 and 163 were imported at the other end. Next, we'll look at beam M14. To search for a specific member, select File, Advanced Selection Run. Then select Find RISA Mark. Type in the mark and that member is highlighted. Right-click and select Edit to open its edit window. You can see that the shear and transfer forces that you just made a note of have been imported. This was a video on importing connection loads from a spreadsheet. Thank you for watching. If you would like to learn more about the connection design capabilities of SDS2, including how to implement a similar process into your specific workflow, then please contact us.